what do you get?
Yeah, x equals 10.
Secant x equals 10. And what quadrant is x in?
Ooh, it's in the fourth.
Okay, so you have secant x equals 10 and it's in the fourth. Let's start at that point.
Okay.
So first thing I'm going to do is take that information and turn it into something a little bit more useful.
Yeah.
I know that the cosine is the reciprocal of a secant, so it's 1/10.
Yes.
And I also know that the cosine is adjacent, right, over hypotenuse. What that will do is it'll allow me to build a right angle triangle where I'll make that adjacent opposite hypotenuse. And the adjacent is 1, and the hypotenuse is 10. So the opposite ends up being eventually the square root of 99. Are you comfortable about where the triangle came from and its sides?
Yes.
Okay, so adjacent, hypotenuse, Pythagoras does the rest. Now, we are being asked to find double angles, and the ones that we're being asked to find are sine, cosine, and tangent. So the sine of 2x is 2 sine x cos x. There are various versions of the cosine of 2x. I'm going to do the 2 cos squared x minus 1 version. And then we have the tangent of 2x, which is 2 tan x over 1 take away tan squared x. Are we happy with those three formulas? You recognize them?
Oh, sorry. For the square root of 99, can that be 3 the square root of 11 as well, or does it have to just stay there?
Right now, I'm just going to leave it as 99, and later on, I'll make it 3 root 11.
Okay.
I kind of do that at the end, just so it's one less thing to worry about until the end. Because sometimes they turn into nice numbers without you having to do anything to them, so it seems a bit extra work otherwise. Okay. Now, technically, I know the sine, the cosine of x, and the tangent of x, and you can see that I'm going to use all of those somewhere in this list. Now, the sine of x is the square root, the opposite, over the hypotenuse, right? It's that guy.
Yes.
But since you're in the fourth quadrant, that guy is negative. I already know the cosine is positive 1/10, and the tangent is opposite over adjacent, which is the square root of 99. But since it's in the fourth quadrant, it's negative. So the reason I'm doing that is to make sure that the numbers I use here have the correct sign, because some are positive and some are negative, and I have to make sure I use the right one.
Okay.
So if I start with the top one, the sine of 2x then is 2 times the sine of x, which is that guy, times the cosine of x, which is that guy. And I end up with, right now, 2 times the square root of 99 over 100. That becomes 3 root 11. The 2 partially cancels with that, and there I've got my first answer, 3 root 11 over 50.
Okay.
You good with that?
Yeah, that one I get.
Okay, so we'll now do the cosine of 2x, and the version I've decided is 2 times the cosine squared, so 1/10 squared, right? Take away 1, and that becomes 2 over 100 take away 1. If you do that in your calculator, you end up with 49, negative 49 fiftieths. So let me try that on my calculator, make sure. 2 divided by 100, take away 1. Math button, choice 1. There we go, negative 49 fiftieths. And the last one of this set then is going to be the tangent to x. And that's going to be 2 times that ugly guy. 1 take away that ugly guy squared. And the two top guys get me -2 square root of 99. And that guy is positive 99. And one take away 99 then gets me negative 98. That guy becomes 3 root 11. That 2 partially cancels with this guy and gets me 49. And the answer is negatives. So there's my third answer. -3 root 11 over 49.
Oh, I am pretty sure that's what I tried because that's what I have written down here. So maybe, did I insert it wrong?
Oh no, if you got it right, that's a good sign. It's kind of hard to do that wrong. I mean, I guess you could forget the 3 by accident or leave it as 99 maybe, but there's not a lot you can really do. Oh, guess what?
What?
2 negatives. The answer's positive.
Oh, negative over negative equals a positive. Okay.
Maybe that's what I did that, so maybe that's what you did. You got it in front of you, you could check it out.
Yeah, I'm opening it up right now.
Okay.
Because I have my work in front of me and I worked it out the same way, but I remember Saanich telling me that I did it wrong. So let me try again. Oh yeah, just the negative. Okay.
Okay, that was easy fix. Okay, where are we off to next?
Let me check. Number 7.
Okay, so we are looking for the cosine of 13/8 pi, and they tell us that we need to use a half angle formula.
Mine has 5/8 pi.
Okay, so we'll change it to 5/8 pi, but we are still going to have to use the exact angle, and they also say exact value, right? So you're not allowed to just plug into your calculator and get 9.1234.
Unfortunate.
So, yeah, it would make life a lot easier.
Yeah.
If they allowed that. Right. Now, if you think of this as the cosine of a half theta, doesn't this become the cosine of 1/2 10/8 pi? Are you comfortable with 5/8 is a half of 10/8 pi? What that is basically telling me is who theta should be in my formula. It should be the 10/8. And now that I've seen that, I probably should tidy it up a little bit. And can't I call it 5/4 pi? Because that's the same thing as 10/8.
And so this is 5/4 pi because when you multiply it by a half, it gets us back to the 5/8.
Yes.
Okay.
And there are lots of ways of looking at it. If you want to figure out who theta is, double that, and you get the answer.
Okay.
Because doubling something that's been halved, doesn't that cancel out and you get what you started with?
Yes.
Right. Now, there is a formula for the cosine of half theta. There's tons of these formula. I'm trying to see if I've got it written down. I meant to keep it. I hope I did. Of course, I kept everything else except that one. Do you have it, Andy?
I have plus or minus the square root of 1 plus cosine x over 2. I don't know if that sounds right.
That is good. Only difference I'm going to do is I'll call it theta then.
Yeah, perfect.
But that's cosmetic. Now, if you're looking at 5/8, the original question, the cosine of 5/8 theta, right, that guy there, is 5/8 pi in the first, second, third, or fourth quadrant, because that's going to decide whether I use the plus or minus for this one.
I think
so
it's in the
second. Yeah, you're right, it's the second. And what's the cosine in the second?
Negative.
So that's why it's the negative. And it's going to be 1 plus the cosine of 5/4 pi, all divided by 2. The cosine of 5/4 pi, I do have my unit circle, at least I've got that handy. And 5/4 pi is way down here, isn't it?
Yeah.
And so it's
Root
negative
2.
root 2 over 2, and the whole thing's over 2. And then we spend ages trying to figure out which version to use. I'm going to use that version. I mean, you can tidy it up in various ways.
Okay.
You want to check that one out? Or it
Yeah,
looks
so
good.
what I did was I put 1/2 as 2/4, and then I tried to combine them. So
Okay, if you want to do that, that's fine. You should have got that guy if you want it all inside the square root. Or that guy if you want to take care of the 4 by taking its square root and getting 2.
oh, okay, so I did that last step wrong. So
That's where it went wrong then. So you did the question right, you're tidying up your style points. There's a bit. If they let you do this one, I would honestly just do this one, right? And you know, not dwell too much in, like there was yesterday, I think I did 5 versions of the same answer, all which were correct.
Yeah.
But, I'm hoping that WebAssign will take this one here.
Okay.
And if it does, just stop there when you get to there.
Let me try to plug it in then.
Right. So this one here you're trying.
Yeah, the 1/2 minus root 2 over 4.
Gotcha. With a minus in front.
Mm-hmm. All right, it looks like it took that one.
Okay, so I think the rule from now on is when you get to here, just call it good.
Yep, just stop.
Just stop, yeah.
Will you remind me why this one's a negative? Is it because the cosine of 5/8 is negative?
Yes.
Okay.
So the cosine of the original angle is negative, and so this should be negative, right? It should be the same sign as the original, because this is that guy, right? It's just we're calculating it in a different way, but we're still calculating the cosine of 5/8 pi, right? So it should still be negative because of the quadrant that the cosine of 5/8 pi is in.
Okay, perfect.
So it looks like the first one was a sign, and the second one was just tidying up the style points. So you're not really getting caught up, it sounds like, at least so far, with the method. You're doing the method okay, it's just a bit at the end that's kind of losing it.
Yeah. Usually I'm okay with following the method, but then when it comes to like knowing how to move square roots around and simplifying, I get a little lost.
I gotcha. Okay.
Could we do number 8? They want us to use the half angle formula to find the exact value of the sine of 23 pi over 12.
Okay, that one. Okay, 23 over 12 pi is in the 4th quadrant. Are you happy with that? It's almost 2 pi, right? It's just shy of it.
Mm-hmm.
Now, doesn't that make this answer negative? Because in the 4th quadrant, isn't the sign going to be negative?
Yes.
So the formula I'm going to be using, and I'll stick to my thetas, I might as well, is the sine of a half theta is plus or minus the square root of 1 plus, I believe it's 1 plus this time, isn't it? Yeah. Let's check it. Yes, it's 1, I take it away. It's 1 minus over 2. Is that correct?
Yeah, 1 minus cosine x, or cosine theta over 2.
Right, and so this fella is going to be the sine of 1/2, and then you double this guy, right? You remember doubling and halving. And we have a bit of a problem here before I start using my formula. I'm going to be finding this as my theta, right?
Yeah. Mm-hmm.
Now, if I simplify that down, it's going to be 23 sixths I. Do you know, right, where is that guy going to be? Well, isn't he more than 2 pi?
Mm-hmm.
So I don't really want to find the cosine of 23/6 because my unit circle doesn't have 23/6 in it, right? And so all I'm going to do is knock off 2 pi, which is essentially 12 of them, and that leaves me with 11/6 pi. So can you see why the theta that I'm going to actually use here is going to be the 11/6 pi version? Are you comfortable with that?
Yeah, so we just multiplied that by 2 to get what it would be, like multiply it by half and it's reverted to the usual answer.
Right, so if you just double this, you've got your theta, right? Because doubling it and then halving it essentially cancels out and you will get back to that. So if you actually found a half of this thing, it would be that guy, because all we're doing is rewriting it in a format that allows us to use the half angle formula.
Okay. And
so,
then,
so
just, and then the 46/12 that we found is more than the 2 pi. So you just subtract it and so it's on the unit circle.
Yeah.
Okay.
So the reason I'm doing that is because I have to get my answers from the unit circle, and my unit circle doesn't have 46/12 and it doesn't have 23/6 either, which is what you get if you take this and just, you know, simplify it a little bit, right? So I'm trying to find a guy that I can use, and I'm looking at 11/6, and I'm looking at a sine, and it looks like the sine of 11/6 is what, negative? Oh, it's a cosine. So it's positive √3/2. So it's take away positive √3/2, all over 2. And then we're not going to make this too awkward, aren't we? Just going to split it like that.
I think I'm getting it square root of 3/2 because that's the cosine. And then you all divide that by 2. Equals,
and then just split it as 1/2 and the other guy over 2, which gets you √3/4.
And this is when you stop and don't keep.
And this is when you stop. Yes.
Okay. Do you want me to put it in, or can we just?
Well, just for, you know, for safety, because I do make mistakes. I feel comfortable if it checks out. I like the method, so if I've done a mistake, it's some trivial thing.
Square root of 3/4. Perfect. Okay.
Okay, so we're getting comfortable with this now.
Yeah, I don't know. Maybe I just wasn't understanding in class yesterday. Sometimes it takes a second for these concepts.
These things take a while to sink in because there's just so much happening. And little fiddly things like doubling something to half it. Oh, but I have to keep track of which quadrant it's in. And then you have to make sure that you use the right value from your unit circle. And then at the end, you got to make it look pretty, but not make a mistake while you're making it look pretty, you know. And so there's all these little funny little, a plus where a minus should go, or something here and something there. And one of those going wrong, you're going to be told you're wrong, because WebAssign isn't generous in saying, well, you were 90% right, and if you'd made that 2 or 4, it would be perfect. You know, it doesn't tell you anything. It just says, hey, that's the answer.
Yeah. Okay. This is another half function one. It's the cosine x is equal to.
What question number is this?
Oh, number 9. Sorry.
Okay,
and I found the half of the sine and tangent, but I couldn't get the cosine one.
Okay, so we are looking for the cosine of a half x, right? That's what we're being asked to find. And they told us that the cosine of x is negative 12/13, and they're telling us that x is this. I'm looking at mine. Let me
mine
do that much.
Negative 40/41.
Okay, so they told you that the cosine of x was negative 40/41, correct?
Yes, and that it's in the 3rd quadrant.
Right, so let's just say that then, right? Okay, so we're good as far as it is concerned. We are being asked to find the half sine, half cosine, half tan, and you were good with two of them, and the one you had trouble with was the cosine one?
Yes.
Now, what is the formula for getting the cosine of a half angle?
It's plus or minus the square root of 1 plus cosine x over 2.
Now, the cosine of x is this number, but we're not finding the cosine of x. We're finding the cosine of a half of it. Now, if you are in the third quadrant, which quadrant is a half of that angle going to be in? We did a little table yesterday which kind of done that.
It's in the first, I think.
Nope, have another look.
Oh, second. There we go.
It's in the second. Now, that's important, right? Because if you're in the second quadrant, right, meaning this angle is in the second quadrant, won't the cosine of it be a negative number? So that's how I knew it was a negative square root and not a positive square root. Does that make sense?
Yes.
The cosine of an angle that's in the second quadrant is a negative thing. Okay?
Yeah.
The next bit will be easy. You basically just plug and chug. You're going to add that ugly fraction. We should make my square roots bigger. And, oh, let's be lazy. Let's get the calculator to do all that because there's a lot of weird fractions going on. So on the top, it's 1, take away 40 41sts, which is that guy, all divided by 2, which is that guy. And then I'll get the calculator to turn it into 1/82. Now, wasn't that a lot easier than trying to do it by hand?
Yeah.
Now,
No, I'm just curious. I'm like, I wonder what I was doing. Oh, you know what? I wrote down 1/81st. Or, yeah, 80 over 81.
Right, now, this one is a little bit different because everything is numbers and there's no square roots involved. So I could split this as that guy, but you could do that's a little bit prettier. Right.
Yeah,
square root
of nothing.
And then, if I'm being really fussy about it, I would do that. And I don't think I can simplify the square root of 82, so that's the answer. So I'm guessing that WebAssign will take that. That would be a much nicer answer. So you're there. If you want to plug it in and we'll see what it looks like.
Yeah, it takes the negative square root of 1 over 82.
Right, so you're good in that. And you know that that's the same as that. So if it takes this, it'll definitely take that.
Yes. Okay.
Are we getting better? I'm trying to get feedback. Are you feeling better now than you were at the start?
No, I am. Yeah, I come into these thinking I'm like doing something
horribly wrong,
but then I just like put the negative in the wrong spot. I'm so close every time.
Yeah.
Okay. Yes, but I am understanding more.
Okay. Well, one here.
Number 10, they want us to find the value of the sum of sine of 135 plus the sine of 45.
Okay, so in this question, you're going to use
addition and subtraction formulas, right?
Well, yeah, exactly. So in this case here, I can't remember. I think I called them A and B's. I hope I did.
Yeah.
There's a formula sine A plus sine B. Great.
Yes.
Right now, you want to write that guy down? I don't know where I've got my one.
Yeah. So I have sine A times the cosine of B plus sine B times the cosine of A.
No, that's not that formula. That's the formula for this. The one you just gave me is that formula. This one has halves in it. And it's a half. of somebody
wonder I
times
did
somebody.
wrong.
Oh, so you're using the wrong formula. Right.
Yeah.
Have you got that guy handy? As I say, I don't know where mine is. In fact, I'm not even sure I bothered to keep it, which is a bit of a pain, because it makes life much easier when you have these formulas in front of you.
Oh, is it the 2 sine a plus b over 2 times?
Oh, here we go. I found it.
Okay, let's see.
And I said
Okay.
there's a half in it, and I take that back. I am wrong. Which is why you should always have formulas handy. And I've just written the wrong formula down again.
Oh no.
Yeah. Okay, tell me what your formula is.
Okay, so I think it would be 2 times the sine of a plus b over 2
Oh, that's where the half is hiding. Times.
cosine of a minus b over 2.
That sounds very familiar. Okay, so in this case, it's going to be 2 times 135 plus 45 over 2. There are so many formulas here. You really need to have like a whole stack of cards next to you, just to keep track of them all. I mean, it'd be great if we had a memory. I don't memorize. I never memorize these ones. I memorize the double angle ones and the a plus b ones and so on. But these ones they're just too many of them, and they don't really get a lot of. You don't need to do them that often. So anyway, here goes. If you add these together, you get 180 over 2. And if you subtract these, I believe you get 90 over 2. So you get 2 times the sine of 90 degrees multiplied by the cosine of 45 degrees. And at this point, my unit circle starts taking over. 90 degrees is basically up here. And the sine of 90 degrees is, there's a sine in it, 1, right? And the cosine of 45 is root 2 upon 2. Oh, how about that? Is a very nice answer.
It's just, is it just root 2?
Yeah. Remark